Everything okay? Fully audible? No, laptop all no problem. Now I am removing it. If everything is okay, okay, I start. Remember, first you have to make a note. See, I will tell briefly, too much I will not explain because this is our class, we are bothered about SFD&BMD. But still, I already given messages for RCC batch and ETAP batch that today's class and also remember next class, tomorrow also required. Reason to thoroughly understand design of combined putting for RCC batch, manual design, and for ETAP batch, how to do by software. So, see, I'll first tell briefly what happens. Imagine there's a footing here. There's a footing plan of the footing. One column is here, one more column is here. And if I take front view, cut here now, you can see length of footing and also depth of footing. Column you can see like this. Now, column will transfer loads. See, these are the column loads. Not only column loads, they will be moment. Can be either like this or like this. That all comes in the software later. I will take one clockwise here, I will take anti-clockwise here. Sometimes both can be clockwise. Sometimes both can be anti-clockwise. That is not a problem. Why? When you do bending moment, you know how to consider couple. Then, see, the load actually you cannot see. It is this way. This moment will be like this way. There is one more moment this way that you cannot see here. This way couple will be there. If you remember, in the RCC class and ETAP class, I called this as M1, this as M2. Remember, this side, see, this is moment about this axis. That is M1 and M2. This is S1, S2. If you remember all, those who are studying SFD&BMD, don't worry about it. Now, see, when you study engineering, at that time combined putting, a theory is given. You provide the projection in such a way that pressure is uniform. That is fully bogus. Why? Because practically column load will keep on changing. For dead load and live load, one column load will come. If you consider dead load, live load plus earthquake, one more load will come. Or if you consider dead load plus earthquake, another load will come. Same way, the moments you are going to get will vary. So, it is not possible to satisfy the condition of what? Resultant column load to pass through exactly CG of the footing. If it satisfies for one combination, other combination, it is spoiled. So, that theory of what? Fixing the projection so that resultant column load will pass through CG of the footing is fully bogus. That I will not tell here, neither in RCC class nor in ETAP class. But I will do it in RCC class for 5th semester BE. No, not 5th semester. Design drawing for BE. Maybe in 8th semester I think, or 7th or 8th. There I will do it. There I won't tell about practical design for them. So, practically, remember, it is not possible to get upward pressure uniform. Upward pressure will always vary along the length. So, it will vary this way and also vary this way. If remember, in the RCC class and ETAP class, I told pressure at any corner equal to plus gross pressure plus 1.1 P by A or net pressure P by A, then plus or minus M1 by Z1 plus or minus M2 by Z2. Tell me, those who are attending RCC class and ETAP class, clear or not? Pressure variation, plus or minus M1 by Z1, plus or minus M2 by Z2, starting term, 1.1 P by A for gross pressure, only P by A for net pressure. Okay, now our subject is SFD&BMD. So, I should give the loading for you. So, remember now, if you have a simply supported beam with double overhang, then if you apply some loading here, some loading, and also some couples here. Okay, now, this is our simply support beam overhang. You invert this one. If you invert this one, whatever this downward load is the upward pressure you are getting this way. Upward pressure. UDL will not come, and whatever this reaction here is what? Tell me. Tell me, in footing case, whatever is this reaction, they are what? Whatever is the reaction for SFD&BMD you consider for simply support beam all, that is what? That is column loads. So, now, what I will do is, I will give a sketch. Those who are interested, I will set a question. See, I will set the question. And remember, those people who study SFD&BMD from my course for another 5 minutes, you never bother what is going on. Why? You need good RCC knowledge to arrive. Finally, what will happen is, we will come to a diagram for which we have draw SFD&BMD. That's what we are covering. See, now, I will give the question for you. Those who are serious or those who think they can manage and get the answer, I'll give a question. See, it will take today's class and tomorrow's class. Okay, see, once upon a time, okay, like a story, there was a combined footing. Okay, leave it. So, there was a combined footing. Okay, see here. Combined footing. The length of the footing, see, remember, the width is a plan. The length and width you have to fix in RCC part. Remember, L1, L2, once you take L1 into L2 square by 6, once you take L2 into L1 square by 6. Remember or not? In RCC. Sometimes for one of the moment, you take area, you take L1, L2. For one of the moment, you take L1 into L2 square by 6. Other moment, M2, L2 into L1 square by 6. Remember or not? Don't remember? Yes, that's all, you don't bother. See, suppose it is possible, somebody is studying SFD&BMD, he will tell what is going on. Wait for some time. A stage will come when RCC will vanish, you get pure strength of materials. Till that time you have to wait. See, a column. Length of column, I will tell 8 meter. And width of this footing stab is 3 meter. Now, there is a column here and one more column here. Column side I will not tell. I will tell here now. Projection of column from left end, projection of center of column from right end. Spacing of columns, I will take 5 meter. Now that also equally important. Two cases are going to come depending on whether columns are near or far off. That I will tell you when I go to SFD&BMD. Okay, now projection N2, 5, 3. Projection on the left side is 1.4 meter. Given in the question. See, how to fix this projection will come in RCC part. Just a minute. I want a colored pen. In time, I won't get color. When I want color, I won't get it now. I know it. Okay, I'll try later. And then automatically, this will become 1.6 meter. See, this 1.4 how it came, 1.7 how it came, 8 how it came, 3 how it came. Of course, 5 is given. 5 is given. Column spacing, all RCC. Then, further given in the question, this column is transferring a load here. This column also transferring a load here. So this distance is 5 meter. Okay. These are the column loads. Now, what I will do is, I will take this point as A, this point as B. Tell why? Because usually support point, I take AB. Next. Further. This offset is what? 1.4 meter. This offset is 1.6 meter. So this is A, this is B, this is C, this is D. Now I require column loads. Just a minute. I should set the column load. Randomly I can't give. You don't bother what I am doing. Around heavy load. Okay. I will take a load of 2000 kilonewton here. No, little more. I want round down. I want total to be multiple of 5. 2200 kN here. Means the column load of the left column is 2200 and corresponding here is 2800 kilonewton. Then there is a moment here from column to footing transferred clockwise of 250 kilonewton meter. Here anti-clockwise of little more 300 kilonewton meter. This moment I don't require. Now, see, now we are going for structural design of footing slab. Punching, shear, all will come there. Now, after you have to fix the depth of the footing. That you don't require today. Then you have required shearing portion for the footing slab. It can be a slab or it can be a beam. If it is a slab type, this is a slab. If it is a beam type, there will be a beam. You never bother that one. Now for us, this is a beam. If it is a slab, beam means some definite width will be there. I don't know how much. Maybe some 500, 600. If it is a slab, width is 3 meter. For SFD&BMD, it hardly matters. So this is a beam connecting the two columns, extending outwards, or this is directly slab. If it is directly slab type, that all you will learn in RCC. Now, I want SFD&BMD for this beam. I will call beam only now. See, start. Question. Therefore, right here, when we have to go for SFD and BMD, that is the main purpose of today's class. A sketch will come here. See correctly. Full board visible. Very important. I want to use the full board. This depth is not required. Okay. I want to calculate. Today, see, I use the full board because I will check it. Yes, because now 1 minute now. This is quality lesser. I can't see anything. Advanced 480. Okay, now okay. 1 minute now. 480 applied. Yes, okay now. Now here 1.4 meter is here. This is 5 meter. 14. Or this is 5 meter I will take. 2.5. Yes, 1.4, okay. This is 1.6 meter. Okay, now, there is a column load here of how much? 2200 kilonewton. There is a column load here of 2800 kilonewton. And very important, this distance is, I write here, 5 meter. This offset left side is 1.4 meter. Right side offset is little more, how much? 1.6 meter. Reasonable scale I maintained. Okay. I maintained reasonable scale. Okay, now this point is, and also, problem. There is a problem now because I want show moments. If I write distance there, moment I cannot show. Okay, I will do one thing. Okay. Now, here there is a clockwise moment. See, I told you, if in between couple comes, always write like this. Today's class, I am taking clockwise here and anti-clockwise here. See. Next question also is there. That is special case. Today's question, outer portion will sag, between column, middle portion will, some portion here will hog. See, elastic curve will be sagging here, and hogging here. So, if you go to reinforcement detailing for this one, bottom steel, and top steel. This is for today's question. This I will tell in RCC. But sometimes, if the columns are very, very close, then BMD will come, full will come sagging. Hogging will not come. Today's BMD will be something like this. See, sagging. See, I am plotting this way, but in RCC, I will plot other way. Tell why? Other way, because there I plot on tension side. Structural design, always you have to plot tension side. Shape same. Now, if the columns are very, very closer, see for example, columns are very closer, offsets are more, then your BMD will come this way. Means what? Full sagging. Then reinforcement required is full bottom heel, full bottom heel. Here, this bottom heel for this BM, this top heel for this BM, this bottom heel for this BM. There, this top, bottom heel for this BM, this bottom heel for this BM, it will be continued. Then, for both the cases, shear post diagram will come like this. I am putting randomly. Randomly, see. Now, high shear post, high shear post. As you go here, shear post reduces. So, up to some distance here, you need closer stirrups. Again, up to some distance here, you need closer stirrups. Here also, closer stirrups here and closer stirrups here. Then, as the shear post reduces, you can go for high, little more spacing. Why? Shear post lesser. This is a shear post diagram. This will come same for both the cases. BMD. One example, overhang portion will sag between column in the some region it will hog. Bottom tail, top tail. And second example, full beam will sag. But for both of them, SFD will be same. And this question I have set so that the upward pressure, the resultant load as you go this way is increasing. Okay, I set it that way. I will see now. Okay, anyway, as you go this way, intensity will increase. When I do next question, I will see that intensity is decreasing. You don't buy out that way. What? Oh, when the sagging bending moment is there, nothing like that. See, the intensity of load will be, it can come either like this or like this, depending on, because of this complete loading, resultant load falls on that side or this side. From center of the footing, if the resultant comes this side, more load here, upward pressure more. Actually, pressure will be in kilonewton per meter square. That kilonewton per meter square, you have to convert to kilonewton per meter. Here, I will convert it. RCC class, I will show you how to convert it. And ETAP class. This class, that's all. Okay, now, this is a question now. See, now 1 minute now. I will tell you finally the question for our course. Some people, this is how much I told? I wrote 250 kilonewton meter, if I remember. This I told little more, 300 kilonewton meter. Okay. Then, distances. See, this distance is 1.4 meter. This is 5 meter. Very important now. Correctly observe. This is 1.6 meter. This point, I will use a color. 1 minute. Want a color for the points. Blue color. Ah, yes, blue color. This point is A. This point is B. This point is C. This point is D. Now, this beam will have, oh, now again, 1 minute. Okay. Loading, I should show down. Looks very odd. Okay, okay. I write once again. Okay. Distance I will put afterwards. Okay. Now, for this beam, there is going to be upward load. Upward load, I will use blue color. I will use blue color, upward load, to understand. Upward load, remember, it is not, it is a pressure which is in kilonewton per meter square is converted to kilonewton per meter. That is, width is cancelled. These all comes in RCC. See, here, this value, these are the pressure. Upward, or this is the upward load due to pressure. That's all. Now do one thing. I will put distance here. See, this distance is 1.4 meter. This distance is, I told, see up to here. This is 5 meter. This is 1.6 meter. Now, anybody can tell me what is this load? What is this load? Let me see. If somebody acts smart with me, I will tell him, okay, now do one thing, show your talent and tell what should be the intensity here, what is the intensity here, so that the complete system is in equilibrium. Most probably 99.9% people will tell that I cannot do. Maybe very small percentage they may try. So then they will also tell not able to do. Then you are talking so many things. Such a simple you can't do means nothing can be done. Now tell me, anybody here can tell me what is the intensity here, what is the intensity here, so that this system is in equilibrium. I know how to calculate. Anyway, it is a question given. So actually everything in the question. Once I enter this one, then I will read the question for you. Okay. Tell me. Anybody can tell? Fast. Anybody can tell me? Tell the answer. What is the intensity on left side? What is the intensity on right side? Fast. If not able means tell no. That's all. Don't waste time. If not able to get means no. That's all. Answer. So that equilibrium is maintained. See, if equilibrium is not maintained, it is a nonsense. Answer barta illa. Yes, answer. Someone told yes. Then tell the answer. Tell the answer. What should be the load left side? What should be the load right side? You are not answering. If you are not knowing, tell no. You don't tell don't know. Tell no. We cannot do it. Instead of wasting time, I am waiting. Tell no. No means okay, no problem. ಏನು answer ಇಲ್ಲ. Simple no will do. No, right now not possible. I need time. You can tell that way. I need time. ಇಲ್ಲ ಬಿಡಿ, ನಾನೇ ಕೊಡ್ತೀನಿ, ನೀವು ಆನ್ಸರೇ ಮಾಡ್ತಾ ಇಲ್ಲ. Even for me, it will take little time, not too much time. See, I will tell you what I am going to do. Don't bother. 2200 into 1.4 plus 2800 into 6.4. I will divide by 1. No. Then plus 250 minus 300. I will divide by 5000. 4.19 meter. 4.19 meter. Correct? 4.19 meter. If it is 4.19 meter, that I am getting a doubt now. 1 minute. 2200 into 1.4 plus 2800 into 6.4 into 6.4 plus 250 minus 300 divided by 5000 is 4.19. So extension is 0.19. Then the pressure here is 5000 divided by 8 minus 5000 into 0.19 into 6 divided by 8 square. 535 point. This is blue color I will write here. This is 535 point. I want full number. 9375 kilonewton per meter. And that answer is 5000 divided by 8 plus 6 into 0.19 into 6 divided by 8 square. 625.106875. Why such a value came? Something wrong. 5000 divided by 8 is 625. 625 plus or minus 5000 into 0.19 into 6 divided by 8 square is 89.0625. So minus 625 is 535 point something. Other one is 625 plus 89.0625 is 714. ನೋಡಿ ತಪ್ಪಾಯ್ತು, ಅಲ್ಲೇ ಗೊತ್ತಾಯ್ತು ನನಗೆ. 714.0625. This much accuracy not required, kilonewton per meter. Or I'll check once again. 5000 divided by 8 plus 6 into 0.19 into 6 divided by 8 square. 5000 divided by 8 plus 5000 into 0.19 into 6 divided by 8 square. Yes, correct. 714 per. This is the question now. See, now I will remove everything. I will tell you what is the question for today for general public. General public means you need not bother what is going on. What is going on? See, there is a beam of total length 8 meter. See, question. Write the question. Those who are serious, write the question. There is a beam of total length 8 meter. Now, it is subjected to two downward point loads of 2200 kilonewton and 2800 kilonewton at 1.4 meter from left end and 1.6 meter from right end, or distance between the 2 point load is 5 meter. Also, at the left contact point where load is acting, there is a clockwise couple of 250 kilonewton meter. At the right side contact point of the point load, there is an anti-clockwise couple of 300 kN meter. Now, the beam is subjected to upward load in the form of trapezoidal loading or uniformly varying load, whose intensity at the left end is 535.9375 kN per meter, which linearly increases to 714.0625 at the right end. Please draw SFD&BMD. That's all. Clear now? General public, this is a question. For RCC batch and ETAP batch, in the combined putting class, I will explain to you what is happening here, or how you got 1.6, how you got 1.4, how you fix the dimensions. This will come in the RCC class and ETAP class. Because when you model by software, it is very essential that during modeling you have to decide these offsets. This 5 meter is fixed, column position is fixed, but offsets you have to decide. It will come in RCC class. So now the question for our SFD&BMD part is simple. Beam of length 8 meter loaded by 2 point loads 2200 kN, 2800 kN at 1.4 from left and also at 1.6 from right, so that between them is 5. Left side where point load is there, clockwise couple 250 kN meter, right side point anti-clockwise 300, and the beam is subjected to upward load in the form of UVL represented by a trapezium whose intensity is 535.9375 at left end and 714.0625 at the right end. Over. Draw SFD&BMD. Do not bother about combined footing, this one, that one, SVC, pressure, nothing. You worry in RCC class and ETAP class. Clear now? Fast. Clear or not? Clear? Fast. Now clear. What is the question? That is the question for today's class. In the SFD&BMD chapter, that is the question. You are not answering. Clear or not? You don't give answer, what I can do? At least, is the question clear or not means no answer, response. Oh, sorry, clear. Okay. Now, start. Now remember, I know nothing about RCC and nothing about ETAP and SAFE. I do not know what is RCC. Okay. I am very good in strength of materials. Start. Now, you can write one note. Somebody is bound to ask, if you want to draw SFD&BMD, this system should be in equilibrium. Remember, if it is equilibrium, reactions you have to calculate to satisfy the conditions sigma m0 and sigma v0. Yes or no? Tell me. It should satisfy the two basic equilibrium conditions. Sigma h is not there. Sigma m0 and sigma v0. Tell me yes or no first. Someone will tell, I will not draw the diagram unless you guarantee that equilibrium is there. If equilibrium is not maintained, when you find SFBM somewhere, look left side or look right side, different answer will come. You know, then I will stop my classes. At any point, if you look left side, one SFBM comes. If you look right side, you get other SFBM. I will stop the class then. Yes. Therefore, what we do is, before you start SFD&BMD, you write, tell my name. KSN gave the question. But who knows? He randomly might have given. If I give random answer here, it will not give equilibrium. Therefore, better check it. Or, like, before giving penicillin injection, what they do? They give a test dose. Why? Because they want to check whether allergic or not. Some reason is there. Penicillin injection to be given. What they will tell? Give a test dose. Now, before I start, I will check equilibrium. Start. Sigma V. See how I got this value. It is not a big issue. Once you understand, it is very simple. But today's class, it is given by me. Start. Sigma V equal to upward positive. Start. Total upward load. Thousands of times I told. Now I will not tell. When uniformly varying load represented by a trapezium is there, total load is always equal to. Tell the answer. Total load is always equal to. Bega, first. When you got a UVL represented by triangular trapezium, total load equal to. It was Beka. Total load equal to. Fast. Time not there. Area of the load diagram. So, answer. 535.9375 plus 714.0625 divided by 2 multiplied by 8. This is the area that will give you upward load, positive, minus 2000, minus 2200, also minus 2800. First, tell me the answer. First, tell me the answer. Tell me the answer. 0. Oh, right. Oh, one of the equilibrium condition is satisfied. Now, second condition, sigma m about any point. You can take about C, any point. I will take about C. Any point will do. Clockwise positive. See, plus 2200 into 1.4 plus 2800 into 1.4 plus 5 is 6.4. Then plus 250, no into, minus 300, then minus moment of this entire load about C. First load 535.9375 plus 714.0625 divided by 2 into 8 is the total load. It will pass somewhere here, multiplied by, from here, resultant line will be here, 535.9375 plus twice of 714.0625 divided by 535.9375 9375 plus 714.0625 into 8 divided by 3. That is the distance of CG from this end. You calculate this answer first. Now my repetition is a stake. Why? Because I gave a problem and asked someone to draw a SFD&BMD where action reaction both are given by me. Action reaction both are given by me. If I make a mistake in giving a reaction or action, then equilibrium is not there. My reputation gone. Answer, bega bega. Bega. Sigma V bantu. Sigma M. Beg body. Fast calculate. Tell the answer. I think you are not calculated. Tell frankly. Someone told 0. Did you really calculate? Someone told 0 there. Did you really calculate or no? Gottilla. Did you really calculate or no? No calculation. Why? Calculated? Okay. You can actually write given the answer 0 without calculation because you are sure that. Do you think I will fall for such traps all? Such things I cannot make mistake. But still, if any calculation mistake is there, I can make out. Some will ask, which calculation? Not required for you. Over. Now, therefore, write 0. So, this load system satisfies sigma V 0 and sigma M 0. Therefore, it is in equilibrium. Now you can go for SFD&BMD. Yes or no? Tell first. Now, green signal, penicillin dose given, no reaction. He was still laughing. Nothing happened. He waited for half an hour. Actually, when you give penicillin, half an hour not required. Few minutes sufficient. If by chance allergy is there, within no time people know it. Half an hour over. Now we will tell, okay, now give him injection. Okay now? Clear or not? Shall I proceed further? Shall I proceed further for SFD&BMD or not? First. Remember, very important example for RCC and ETAP. No response. Shall I proceed further for SFD&BMD or no? Proceed. Thank you. Okay. Now, you write all these things. Some will start wondering, how it came? Actually, nothing is there. Once you know all the basic principles, these are all nothing. Okay, now start. One very important, see, SFD&BMD means we want a complete solution. Why? You require even point of contraflexion also. Tell why, tell me. Because point of contraflexion required because up to some distance bottom bar, then you require top bar. So you should know up to where you require bottom bars from the ends and from where onwards you require top bar. So point of contraflexion is also required. Or we want complete solution for this one. Remember, second question, I will not explain this much. Why? I will bring the two columns nearby and I will tell, now calculate. More work is for you then. Same as today. Okay, start. Now, right, ready for SFD&BMD. Okay, we will complete. Suppose this is not completed today, nothing to worry. Because another class is required. There, second question, I need very lesser time. Just 15-20 minutes. Why? It is same as this question. Something will happen. It will happen. That's all. Their contraflexion is not there. Okay, start. Now, one powerful note. When you write SFD&BMD, see, if I want SFBM here, if I look this side, I want this load and moment of that load. If I want here, I want either this much load or that load. If I want somewhere here, I want this side load or that side load. Suppose you want to locate contraflexion, some unknown point, you need this side load or that side load. It will give difficulty. So what I do is, see, right here, before we start SFD&BMD, see here, before we start SFD and BMD, what we will do is, we will consider only the upward load, which is in the form of a trapezium or uniformly varying load. See, there we will take a section XX at X from one of the ends, either left end or right end, your choice. I will take from left end, your choice. One, you can't waste time, left or right or left or right or left side you will take. Then in term at X from left end, we will get what is the shear force there, what is the bending moment there, only due to this UVL. Okay. Later, real SFBM is that one and other things. So, see here, consider you what all I told you, write first. What I am going to do, I told you now. We will consider only upward UVL and get expression for SF and BM at any section XX only due to that upward load. Sorry, consider section XX, sorry, red color, section XX at X from left end A. Now, left end C. Now, do not bother, is it before A or after A? Don't see upper side. You do one thing, never see upper side. See only UVL. Only UVL. I want C here and D here. Total length is 8 meter. That's all. 8 meter. UVL is like this. This way. This is 535.9375 kilonewton per meter. This is 714 point, full length, scale is not there, 714.0625 kilonewton per meter. And I see, I am going to close my eyes, I am taking a random section. I am not telling, see, the point A and B will not come here. From C to D, it is single variation. So, close your eyes. Oh, that way. Section XX. I will take at X from here. So, X is from here. Now, tell me, if I want answer at A, substitute X equal to, first, if I want answer at A, substitute X equal to, Vega. Substitute X equal to, if I want any answer at A, later, substitute X equal to, how much? X is from left end, remember. Suppose later I want answer at A, substitute X equal to 1.4 meter. Later I will not tell. If I want answer at B, substitute X equal to, Vega. First, if I want answer at B, substitute X equal to 6.4 meter. Why? This distance. Suppose I want D, X equal to 8 meter. If I want C, X equal to 0. Clear? Now, this intensity is called intensity W at the point X. Red color. W at the point X. Okay. That value I want. Tell me how to get the value. I want that value. What to do? First tell me, see, this way it is going. We know that intensity W at X equal to, intensity W at X equal to 535.9375 plus 714.062. Oh, that is all time. Okay. Intensity W at X equal to, red color X. Okay. Equal to 539.9375 plus plus because increasing 714.0625 minus 535.9375 divided by 8 multiplied by x. This much kilonewton per meter. Tell me, clear or not? It is 535 point, 535.9375 plus 714.0625 minus 535.9375 divided by 8 into x. Fully clear? First, this I am not going to explain because in the SFD&BMD course earlier I told it so many times, and also in my YouTube channel there is a chapter, there is a classes called Mathematical Concept and Tricks. There, class number 3, I made complete clear interpolation. People who are lazy, who are not going to see that one, thinking that they know everything, if it is not clear, they should pay the penalty. In my class, once I explain thoroughly, I should not explain, but still you know, so many things explain again and again. Or if I simplify, this will become 535.9375 plus, tell this number first, tell this number, 714.0625 minus 535.9375 divided by 8 into x number. See, this ordinate is this ordinate plus that minus this divided by 8 into x. 22 full number ಬೇಕು ನನಗೆ ಚಿಲ್ಡ್ರೆ, ಫುಲ್ ನಂಬರ್, ಒಂದು ನಯಾ ಪೈಸಾ ಚೇಂಜ್ ಬರಬಾರ್ದು. ಸಿ 22 ಪಾಯಿಂಟ್ ಫುಲ್ ನಂಬರ್ ಬೇಕು ನನಗೆ. 22 ಪಾಯಿಂಟ್, ಯಾಕೆ ಚೌಕಾಸಿನೇ ಇಲ್ಲ ಇವತ್ತು. 22.265625 22.265625 times x. X. Tell, correct or not? This much kilonewton per meter. Clear now? Tell me. Clear or not? I don't want round off. Actually, practical design you can round off. You can write here 535.94, 714.06. You can write what? 535.94 plus 22.266 you can write. But not in my class now. Okay. Now, remember, next problem what happens is, it is going to decrease from here. Maybe next class, this is randomly. See, this is suppose say 650. This will come 350. Now, next class I will tell it is 650 minus 350 divided by 8 into x. So, next time I will write what? 650 minus 350 divided by 8 into x. Actually, not this number. It will come that way. Why? Decreasing trend. Okay. That all I explained thoroughly in the mathematical class. Okay, now over. Okay, now you know the answer. So I will do one thing. I will enter here. It is 535.9375 plus 22.265625 multiplied by x. Or you can do one thing. You can check the answer. Substitute x equal to 0. Tell the answer. In the equation here, substitute x equal to 0. Tell the answer. You get the intensity at left hand. What is the answer? Substitute x equal to 0. You get the intensity at the left hand. How much answer? Tallying or not tallying? Tell me. Tallying. Okay. Substitute x equal to 8. You should get this intensity. Check the answer. Substitute x equal to 8. You should get this intensity. Getting or not getting? substitute x equal to 8 meter. Are you getting or not? No, getting. Okay, that means correct. Over. Now see. This all I will remove now. Sketch is there. I am removing this one now. Okay. Now what you do is, see, let v dash x and m dash x be respectively shearing force with the left up right down positive and bending moment with the sagging positive at xx due to only the UVL, only this upward UVL. It is not the real. That's why I put a dash. See, later when you want SFDM, you don't have struggle. You make an answer ready. Only due to upward UVL means if I see here, look left side, what is the shear force, what is the bending moment? It is not the real. See, if I stand here, real shear force is this load and that load is there. Real BM is this BM and that BM and this will come. Considering only UVL, everything get out. Therefore, your V dash X, red color, equal to, I told 1000 times, if you want shear force, look left side. Left up is positive, plus only load, this much load. How much, tell me? It is only this much load. Shear force is what? Only, look this side, net load, only load. It is 535.9375 plus our, one bracket I will put here. One more value, 535.9375 plus 22.265625 times x. That one divided by 2 multiplied by x. Why? Only load, only area. Or I will do one thing now. Somewhere there I will put the answer. See, I want that answer now. Therefore that V dash x equal to, tell the answer, 535.9375 plus 535.9375 divided by 2 into x. Tell the answer. It is 535.9375 times x. Why? See, same number 2 times divided by 2 into x. Then plus, tell the answer, 22.265625 divided by 2 plus 11 point, big answer, you ಹೇಳ್ತಾ ಇಲ್ಲ, 22.265625 divided by 2 is 11.132812 times what? See, there is a x here into x. That much what? Tell me. That much what? That much not x. That much what? That much what? X or x square? That much x or x square? X. ಅಯ್ಯೋ, ಇಲ್ಲೊಂದು x, ಇಲ್ಲೊಂದು x. ನೋಡಿ, ಅದಂಗೆ that much x. How it is x? It is x square. X square. This only will tell you shear force variation for UVL is what? Tell me. This only will tell you that shear force variation due to UVL is what? ನೋಡಿ, ಇದೇ ಹೇಳ್ತಾ ಇದೆ. This only will tell you shear force variation is parabolic of second degree. Correcta? Clear or not? Nanu hurry madodilla. Do you want to hurry and finish fast or systematically complete? Tell me. If you want, I can hurry and finish. No, because this is once in a time chance for you. This is once in a lifetime chance of correctly understanding SFD&BMD for combined porting. No books will tell you this much. And for that matter, I will tell you, nobody will tell you this much. I am sure. No, if someone is telling, okay, good. But I am so sure that much patience people are not having. They will tell, draw the diagram. Okay. This is the expression for shear force only due to what? Remember, I write here. Expression for shear force only due to upward UVL. Over. Now, I will remove this one now. Now I want second one. Okay. Second one. Little careful now. This diagram is vanishing now. Hey, get out this diagram. Okay. Start. Now I want, ಸ್ವಲ್ಪ ಜಾಗ ಬೇಕಿಲ್ಲಿ, ಇಲ್ಲಿ ಬರೀತೀನಿ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಎಕ್ಸ್, ಅಲ್ಲಿ ಜಾಗ ಇಲ್ಲ, ಐ ಪುಟ್ ಎಕ್ಸ್ ಹಿಯರ್. ಓಕೆ, ರೆಡ್ಡಲ್ಲಿ ಬೇಡ, ರೆಡ್ ಪ್ಲಸ್ ಆಯ್ತು ಬಿಡಿ, ಬೇಡ, ರೆಡ್ಡಲ್ಲಿ ಬರೆಯೋಣ, ರೆಡ್ ಎಕ್ಸ್. ಓಕೆ, ನಾವು ಎಮ್ ಡ್ಯಾಶ್ ಎಕ್ಸ್ ಇಲ್ಲಿ ಬರೆಯೋಣ. ಎಮ್ ಡ್ಯಾಶ್ ಎಕ್ಸ್ sagging positive is the bending moment here due to only this upward load is total load first. How much? 535.9375 plus what? On the bracket plus ಇನ್ನೊಂದು 535.9375 plus 22.265625 times x means what? Sum of the two ordinates divided by 2 multiplied by what? X. This will give what? Tell me. 5 this side plus this side divided by 2 into x. Tell me what it will give you. Tell fast. What it will give you? Sum of the two parallel sides divided by 2 into x. What it will give you? No, load correct. Area of the load diagram. I am asking, area of load diagram will give what? ನೀವು ಹೇಳ್ತಾ ಇಲ್ಲ. Area ಬೇಡ ನನಗೆ. Structurally, area of the load diagram will give what? Correct, area correct. Area of the load diagram will give, allalla, don't worry about this one, shear force. It will give what? Shear force ಆಮೇಲೆ. Area of the load diagram will give you shear force. ನಾನು ಹೇಳೇ ಇಲ್ಲ ಆ ಥರ. I never told that way. I told already that you convert to shear force. Area of the load diagram, ನೋಡಿ ನೀವು ಸರಿಯಾಗಿ ಬರೀತಾ ಇಲ್ಲ. Area of the load diagram will always give. ನಾನು shear force ನ ಹೇಳೇ ಇಲ್ಲ. ಯಾಕೆ? ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಮಾಡ್ತಾ ಬೇಡವಾ? ವೆನ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ, ನೋಡಿ ಆನ್ಸರೇ ಮಾಡ್ತಾ ಇಲ್ಲ. ಯಾರೋ ಆನ್ಸರ್ ಕೊಟ್ಟರಲ್ಲಿ ನಂದಕುಮಾರ್. ಇಟ್ ವಿಲ್ ಗಿವ್ ಯು ಟೋಟಲ್ ಲೋಡ್. ಹೌ ಮಚ್ ಈಸ್ ದಿಸ್ ಮಚ್ ಲೋಡ್? ನಾವು ಲೋಡ್ ಓವರ್ ಇಂಟು ವಿ ನೀಡ್ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್. ಕರೆಕ್ಟ್? ಲೋಡ್ ಇಂಟು ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್. that distance formula is there. I am not writing formula because how many times I have to explain, right? So this into, nodi, what into? Moment into this distance. That distance is illinda ಬೇಕು ನನಗೆ. I want moment about this point. Why? When I want bending moment here, distance should be from here into this distance is this side. It is 535.9375 plus 22.2625 times x. That side, plus this side, plus twice of this side, twice of 535.9375 divided by that side plus this side. It is 535.9375 plus 22.2625 times x, that side plus this side 535.9375 into x divided by, tell how much, if you are here, this side plus twice of that side divided by this side plus that side into distance between the two sides divided by 3. ಆಯ್ತು. Now if you observe correctly, it always happens for trapezium. ನೋಡಿ ಇಲ್ಲಿ 535.9375 plus this number will cancel with this number. It always happens. ಯಾಕೆ? ಲೋಡ್ ಮಾಡ್ತಾ a plus b by 2 into h, ಡಿಸ್ಟೆನ್ಸ್ ಮಾಡ್ತಾ a plus 2b by a plus b into h by 3. ನೋಡಿ, ಇದು ಯಾವತ್ತು ಕ್ಯಾನ್ಸಲ್. ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ದಿಸ್ ಟರ್ಮ್ ವಿಲ್ ಕ್ಯಾನ್ಸಲ್ ವಿತ್ ದಿಸ್ ಟರ್ಮ್. ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ಫಾಸ್ಟ್ ಬೇಗ ಹೇಳಬೇಕು. ಇಟ್ ವಿಲ್ ಕ್ಯಾನ್ಸಲ್. ಇಫ್ ಯು ಡೋಂಟ್ ಕ್ಯಾನ್ಸಲ್, ಯು ಆರ್ ವೇಸ್ಟಿಂಗ್ ಯುವರ್ ಟೈಮ್. ಎಸ್, ಓಕೆ. ನೌ ಈಕ್ವಲ್ ಟು ಹೇಳಿ ಆನ್ಸರ್. ಎಕ್ಸ್ ಬೈ 2 ನೋಡಿ, ಎಕ್ಸ್ ಬೈ 2 ಟೈಮ್ಸ್, ಟೆಲ್ ಫಾಸ್ಟ್, 535.9375 ಪ್ಲಸ್ 2 ಟೈಮ್ಸ್ ಆಫ್ 535.9375. ಆನ್ಸರ್ ಬೇಗ. 535.9375 ಪ್ಲಸ್ 2 ಟೈಮ್ಸ್ ಆಫ್ 535.9375. ಆನ್ಸರ್ ಬೇಗ. ನಂಬರ್ ಫಸ್ಟ್ ಬೇಗ ಇರಬೇಕು. 535.9375 ಪ್ಲಸ್ 2 ಟೈಮ್ಸ್ ಆಫ್ 535.9375. ಆನ್ಸರ್ ನೋಡಿ. ನನಗೆ ಅವರು ಬೈತಾರೆ ಇವಾಗ, ಸಂಬಡಿ ವಿಲ್ ಸ್ಕೋಲ್ಡ್ ಮೀ ನಾವು. ಬೇಗ ಬೇಗ. ಇದಾಯ್ತಲ್ಲ, ಎಕ್ಸ್ ಬೈ 2 ಔಟ್ಸೈಡ್ ಇಂಟು ದಿಸ್ ನಂಬರ್ ಪ್ಲಸ್ ದಿಸ್ ನಂಬರ್ ವಿದೌಟ್ ಎಕ್ಸ್, ಸಮ್ ಆಫ್ ದೋಸ್ ಟು ಎಷ್ಟು? 1607.8125. ದೆನ್ ಡಿವೈಡ್ ಬೈ 3 ಇದೆ. ಟೆಲ್ ಮಿ, ಡಿವೈಡ್ ಬೈ 3 ಮಾಡಿ. ಹೇಳಿ ಬೇಗ. ಡಿವೈಡ್ ಬೈ 3 ಮಾಡಿ. ಎಷ್ಟು? ನೋಡಿ, ಈಗ ಕೆಲವರು ಬೈತಾರೆ, ಸಾರ್ ಏನು ತಮಾಷೆ ಮಾಡ್ತೀರಾ ಸಾರ್, ಮುಂಚೆ ಹೇಳಿದ್ರೆ ನೋಡಿ, ಇದು ಎ ಪ್ಲಸ್ 2a ಡಿವೈಡ್ ಬೈ 3 ಅಂದರೆ ಸುಮ್ಮನೆ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತೀರಾ ಅಂತ. ಎಷ್ಟು ಆನ್ಸರ್? ಆನ್ಸರ್ ನೋಡಿ, ತಪ್ಪು ಕೊಟ್ರಾ? ಡಿವೈಡ್ ಬೈ 3. ಅಯ್ಯೋ, ಈ ಥರ ಮಿಸ್ಟೇಕಾ? 535.9375 plus twice of 535.9375. You add these two, then divide by 3. ಅಲ್ಲಿಗೆ ಬಂತು. ಎಷ್ಟು? ಇಟ್ ವಿಲ್ ಕಮ್ 535.9375. ಅಲ್ಲಿಗೆ ದಿಸ್ ಈಸ್ ಓವರ್ ಆ್ಯಂಡ್ ದಿಸ್ ಈಸ್ ಓವರ್. ದೆನ್ ಹೊರಗಡೆ ಎಕ್ಸ್ ಇದೆ, 3 ಅಕೌಂಟ್ ಆಯಿತು. ಇನ್ನೊಂದು 22.2625. ಏನದು? 22.2625 ಅಲ್ಲ, 22 ಪಾಯಿಂಟ್ ಎಷ್ಟದು? ಸಾರಿ 22 ಪಾಯಿಂಟ್, ಅಯ್ಯೋ 2625 ಅಲ್ಲ, 22.265625. 265625. Now tell the answer. 22.265625. 22.265625. Okay. 22.265625 divided by 3. Answer. ಬೇಗ ಬೇಗ. 22.265625 ಡಿವೈಡ್ ಬೈ 3. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಅಯ್ಯೋ, 22.265625 ಡಿವೈಡ್ ಬೈ 3. ತುಂಬ ಹೊತ್ತಾಗ್ತಾ ಇದೆ. ಯು ಆರ್ ನಾಟ್ ಪಾರ್ಟಿಸಿಪೇಟಿಂಗ್. ಸಿ, ಐ ಕ್ಯಾನಾಟ್ ಡೂ ದ್ಯಾಟ್ ವೇ. ಯು ಶುಡ್ ಡೂ ಇಟ್. 22.5625 divided by 3. 7.421875 plus 7.421875 times what? Times what? Tell me. ಅಯ್ಯೋ, ಇದು ಮರ್ತೋಯ್ತು. ಇಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ, ಇಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ ಅಲ್ಲ, ಅಲ್ಲಿ ಅಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ, ಮರ್ತೋಯ್ತು, ಇರೀ. ಎಸ್, ಇಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ. ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ವಾಟ್? ಟೆಲ್ ಮಿ. ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ವಾಟ್? ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ಎಕ್ಸ್, ದೆನ್ ಔಟ್ಸೈಡ್ ಇಂಟು ಒನ್ ಮೋರ್ ಎಕ್ಸ್. ಟೆಲ್ ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್? ಇನ್ನೊಂದು ಎಕ್ಸ್ ಇದೆ, 22.5625 ಟೈಮ್ಸ್ ಎಕ್ಸ್ ಡಿವೈಡ್ ಬೈ 3 ನಂಬರ್ ಬಂತು. ದಟ್ ಮಚ್ ಎಕ್ಸ್ ಇಂಟು ಔಟ್ಸೈಡ್ ಒನ್ ಮೋರ್ ಎಕ್ಸ್ ಈಸ್ ದೇರ್. ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್? ಟೆಲ್ ಮಿ. ಈಸ್ ಇಟ್ ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್? ನೋ, ಐ ಡು ನಾಟ್ ವಾಂಟ್ ಎನಿ ಮಿಸ್ಟೇಕ್. ಈಗ ಚೆಕ್ ಮಾಡ್ತೀನಿ ನಾನು, ಗಾಬರಿ ಆಗಬೇಡಿ. ಈಗ ಚೆಕ್ ಮಾಡ್ತೀನಿ ನಾನು ಆನ್ಸರ್ನ. ಯು ಟೆಲ್ ಮಿ ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್. ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್ ಯು ಟೆಲ್. ಒಂದು ಎಕ್ಸ್, ದರ್ ಇಸ್ ಎ ಎಕ್ಸ್ ಹಿಯರ್. ಮೇ ಬಿ ರೈಟಿಂಗ್ ಪ್ರಾಬ್ಲಮ್. ಯು ರೈಟ್ ನೀಟ್ಲಿ ಒನ್ಸ್ ಅಗೇನ್. ನೋಡಿ, ಆನ್ಸರೇ ಮಾಡ್ತಾ ಇಲ್ಲ. ಇಲ್ಲಿ ಬರೀತಾ ಒಂದು ಎಕ್ಸ್ ಮರ್ತ್ಬಿಟ್ಟೆ ಆಗ. ಇಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ ಅಲ್ಲ ಜೊತೆಗೆ. ನೋಡಿ, ಅದು ನೀವು ಅನ್ಸ ಇಲ್ಲ. ಈಸ್ ಇಟ್ ಕರೆಕ್ಟ್ ಆರ್ ರಾಂಗ್ ವಾಟ್ ಐ ರೋಟ್? ಈಸ್ ಇಟ್ ಕರೆಕ್ಟ್ ಆರ್ ರಾಂಗ್? ಎಸ್, ಓಕೆ. ಆರ್ ದೇರ್ ಫೋರ್ ಐ ವಿಲ್ ರೈಟ್ ಎಮ್ ಡ್ಯಾಶ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು, ನೋಡಿ, ಎಮ್ ಡ್ಯಾಶ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು sagging positive, that is the bending moment here, looking left side, considering only upward load. Remember, I will give last statement equal to ಆಗೋಯ್ತು ಹೇಳಿ 535.9375 ಡಿವೈಡ್ ಬೈ 2 ಹೇಳ್ತೀರಾ? ಬೇಗ ನೀವು ಕೊಡಲ್ಲ, ನೀವು ಕೊಡ್ತಾ ಬೆಳಿಗ್ಗೆ ಆಗತ್ತೆ. 535.9375 ಡಿವೈಡ್ ಬೈ 2 ಮಾಡಿದ್ರೆ 267.96875 ಟೈಮ್ಸ್ ವಾಟ್? ಇಲ್ಲೊಂದು ಎಕ್ಸ್, ಇಲ್ಲೊಂದು ಎಕ್ಸ್, ಇಲ್ಲೊಂದು ಎಕ್ಸ್. ವಾಟ್? ಟೆಲ್ ಮಿ. ಒನ್ ಎಕ್ಸ್ ಇಯರ್, ಒನ್ ಮೋರ್ ಎಕ್ಸ್ ಇಯರ್. ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ವಾಟ್? ಬೇಗ ಹೇಳಬೇಕು. ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ವಾಟ್? ದಟ್ ಮಚ್ ಟೈಮ್ಸ್. ನೋಡಿ, ದೇರ್ ಇಸ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಯರ್. ಒನ್ ಔಟ್ಸೈಡ್ ಎಕ್ಸ್ ಇಸ್ ದೇರ್, ಒನ್ ಮೋರ್ ಎಕ್ಸ್ ಇಸ್ ದೇರ್. ದಟ್ ಮಚ್ ಟೈಮ್ಸ್ ವಾಟ್? ನೀವು ತುಂಬ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ದಟ್ ಮಚ್ ಟೈಮ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್. ದಟ್ ಮಚ್ ಟೈಮ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಇನ್ನೊಂದು ನಂಬರ್, ಎಷ್ಟು? ಇಲ್ಲೇ ಇದೆ, 7.421875 ಡಿವೈಡ್ ಬೈ 2. ಬೇಡ, ನೀವು ಕೊಡ್ತಾ ಬೆಳಿಗ್ಗೆ ಆಗುತ್ತೆ. 7.421875 ಡಿವೈಡ್ ಬೈ 2 ವಿಲ್ ಗಿವ್ ಯು 3.71 09375 times, tell what? X. Power of X. ಇಲ್ಲೊಂದು ಎಕ್ಸ್, ಇಲ್ಲೊಂದು ಎಕ್ಸ್, ಇಲ್ಲೊಂದು ಎಕ್ಸ್. ಪವರ್ ಆಫ್ ಎಕ್ಸ್. ನೋಡಿ, ರೆಸ್ಪಾನ್ಸೇ ಇಲ್ಲ. ಪವರ್ ಆಫ್ ಎಕ್ಸ್. See, little struggling required to understand the concept. Otherwise, this will never be clear. You are not telling answer. Power of X is what? Not that I am not knowing. Power of X is 0 now. 3. That much cube. Okay. This only will tell you BM variation due to uniformly varying load is parabola of third degree. Correcta? Artha aita? This will tell second degree, shear force is second degree, BM is third degree, BMD. Clear now? This only will tell you adu second degree parabola, this is third degree parabola. Tell clear or not? Bega. Clear. 0 no? 0 ಅಂದರೆ ಗೊತ್ತಾಗಿಲ್ಲ, ಯಾರೋ 0 ಅಂದರು, ಅದು ಪ್ರಿಂಟ್ ಮಿಸ್ಟೇಕಾ? ಆಯ್ತು ಬಿಡಿ, ಕ್ಲಿಯರ್. ಓಕೆ. ಎಸ್, ಓಕೆ. ನೌ ರಿಮೆಂಬರ್, ಐ ವಿಲ್ ಟೆಲ್ ಲಾಸ್ಟ್ ಟೈಮ್, ವೆನ್ ಯು ವಾಂಟ್ ಶಿಯರ್ ಫೋರ್ಸ್ ಹಿಯರ್ or shear force here or shear force here, wherever shear force is there, this loading side you have to see. If you want shear force or BM due to upward load, you don't calculate. Use this expression to get shear force due to upward UVL. Use this expression to get BM. Substitute X from C. If I wanted A, put X equal to 1.4. If I wanted B, put X equal to 6.4. If I wanted D, put X equal to 8. If I wanted C, put X equal to 0. Clear aita? Bega. So suppose I want bending moment here. What I will do? This BM is here. Then minus 2200 into that I will write. I will real BM SF means what? Not only this one, they are also there. Now you need not worry about this loading now. Ready-made answer. First tell me clear. I will tell you some interesting point. First tell me clear. I will tell you some interesting point. Clear? Okay. Now do one thing. Tell the answer. Writing shear force is very easy because this side plus this side divide by 2 into X. See, very easy. Yes or no? Tell first. Writing shearing force is very easy. Yes or no? Nodi, yake? Shear force equal to only area. The sum of the two sides divide by 2 into X. Tell me yes or no? You should answer it now. Writing the shear force is very easy. If you tell yes, I will tell how easily you can write bending moment. Yes. You know that rate of change of bending moment with respect to X is shear force. Therefore, bending moment is integration of shear force. Correct? So, differentiation of bending moment is shear force, or bending moment is integration of shear force. Simply integrate this one. You integrate this one. You need not bother about boundary conditions because integration constants are going to be 0 because when X equal to 0, shear force equal to 0. When X equal to 0, bending moment equal to 0. So constant will come. You need not bother because at the extreme end, when X equal to 0, constants are, your shear force BM are 0, constant will become 0. Now integrate. Now this you can write very easily. Now 535.935 X becomes 535.9375 into X square by 2. So divide by 2 ಮಾಡಿ. Tally ಆಗ್ತಾ ಇದೆಯಾ? ಬೇಗ ಹೇಳಿ. Tallying or not tallying? Fast. Tallying or not tallying? Tallying or not tallying? ಬೇಗ ಕರೆಕ್ಟಾ? ಆಮೇಲೆ ಇಲ್ಲಿ ಬನ್ನಿ. 11.1328125 X square becomes X cube by 3. ನೋಡಿ X cube. ಇನ್ನು divide by 3 ಮಾಡಿ. Are you getting this number? Divide by this 1 by 3. Yake? X square becomes X cube by 3. If you divide by 3, X square becomes X cube. Are you getting this number? Bega. Are you getting that number? Tell me. Are you getting that number or not? Answer ಕೊಡ್ತಾ ಇಲ್ಲ ನೀವು. If you integrate that one, are you getting the BM equation? Yes. Therefore, these are all not required. See, shear force you can write directly. Why? Sum of the two sides divide by 2 into X. Bending moment ಮಾಡ್ತಾ I can tell this ಮೊದಲೇ ಹೇಳ್ಬೋಯಿತ್ತು ನಾನು. Why I am not told? You should struggle once, then remember. But that is possible only if constant of integration is 0. I will guarantee it is 0 for this case because it will become m plus constant. When X equal to 0, BM equal to 0, it will become 0. Okay, now clear? If you get to V equation, integrating that you get M equation, or if you differentiate M, you will get back the V equation. If you differentiate M, you will get back the V equation. Okay, now do one thing. In this equation, you substitute X equal to 4 point ನಾನು ಮರ್ತೋಯ್ತು. .19 meter. You do not ask me why I am doing it. ನಿಮಗೆ ಬೇಡ ಇದು, ತಮಾಷೆಗೆ. In this equation, substitute x equal to 4.19 meter. ಹೇಳಿ ಆನ್ಸರ್. ನಾನು ಹೇಳ್ಬಿಡಿ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, ಸುಮ್ಮನೆ ತಮಾಷೆಗೆ, ಫಾರ್ ಜಾಲಿ ಪರ್ಪಸ್. You don't bother, don't ask me, sir, what is that number? No, my own personal number. In this equation, you substitute x equal to 4.19 meter. What you get? ಇಲ್ಲ 4.1 ಆಯ್ತು ಬಿಡಿ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಬೇಡ, 4.9 ಬೇಡ, ಇರ್ಬಿಡಿ, ಕಷ್ಟ ಆಗುತ್ತೆ ನಿಮಗೆ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗೋದು ಕಷ್ಟ. ಅದು ಯು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಬೇಡ ಹೇಳ್ತೀನಿ ಎಷ್ಟು ಅಂತ. ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 8 ಮೀಟರ್. ಬೆಟರ್ ಹೇಳಿ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 8 ಮೀಟರ್. ಹೇಳಿ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 8 ಮೀಟರ್ ಎಷ್ಟು ಬರುತ್ತೆ ಬೇಗ. ಇನ್ ದಿಸ್ ಇಕ್ವೇಷನ್ you substitute x equal to 8 meter. Answer ಬೇಗ. x equal to 8 meter. 49 ಯಾಕೋ ಡೌಟ್ ಇದೆ ನನಗೆ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಪುಟ್ x equal to 8 meter. ಸುಳ್ಳು ಹೇಳ್ಬೇಡಿ, ನಾನೇ ಮಾಡಬೇಕಾ? ಇದು ಅಗತ್ಯ ಇಲ್ಲ, ಸುಮ್ಮನೆ ತಮಾಷೆಗೆ. ಎಷ್ಟು ಬಂತು? 19050 ಬಂತು, 050. ಈಗ ಟೇಕ್ ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್, ಫೈಂಡ್ ಮೊಮೆಂಟ್ ಆಫ್ ದಿಸ್ ನೆಟ್ ಲೋಡಿಂಗ್ ಅಬೌಟ್ ದಿಸ್ ಪಾಯಿಂಟ್. ಹೇಳ್ತಾ ಹೋಗ್ತೀರಿ, ಯು ಶುಡ್ ಟೇಕ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಪಾಸಿಟಿವ್, ನಾಟ್ ಕ್ಲಾಕ್ ವೈಸ್ ಪಾಸಿಟಿವ್, ಬಿಕಾಸ್ ದಿಸ್ ಈಸ್ ದ ಕ್ಲಾಕ್ ವೈಸ್ ಮೊಮೆಂಟ್ ಆಫ್ ದಿಸ್ ಲೋಡ್. ಟು ಬ್ಯಾಲೆನ್ಸ್ ದಟ್ ಒನ್, ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಮೊಮೆಂಟ್. ಆರ್ ಟೇಕ್ ಯುವರ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್, 2000, or do one thing, 2200 into, you calculate 2200 into 6.6 plus 2800 into 1.6 plus 300 minus 250. That is the net anti-clockwise moment there. This answer has to tally with this number. Otherwise, today only you close the class. ಇವತ್ತೇ ಕ್ಲಾಸ್ ಕ್ಲೋಸ್ ಮಾಡೋಣ, ಬೇಡ, ಪಾಠನೇ ಬೇಡ. ಎಷ್ಟು ಬಂತು? ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಎಷ್ಟು ಬಂತು? ಹಿಯರ್ ಆನ್ಸರ್ 2200 into 6.6, 2800 into 1.6 and minus 2 plus 300 minus 250. ಎಷ್ಟು ಬಂತು ನೋಡಿ, ಎಷ್ಟು ಬಂತು? ಸೇಮ್ ಬಂತ ಆನ್ಸರ್. ವೈ ಟೆಲ್ ಮಿ? ಬಿಕಾಸ್ 19050 is the net moment like this. For equilibrium, it should be equal to net moment like this. ಸುಮ್ಮನೆ I will not tell I am going to close the class. ಅಷ್ಟೊಂದು ಈಸಿಯಾಗಿ ಒಪ್ಕೊಳ್ಳೋದು, ಐ ವಿಲ್ ನಾಟ್ ಕ್ಲೋಸ್ ದ ಕ್ಲಾಸ್. ಸಚ್ ಮಿಸ್ಟೇಕ್ಸ್ ವಿಲ್ ನೆವರ್ ಹ್ಯಾಪನ್ ಬೈ ಮೀ. ಬೈ ಮಿಸ್ಟೇಕ್ ಆಲ್ಸೋ ವಿಲ್ ನಾಟ್ ಹ್ಯಾಪನ್. ಟ್ಯಾಲಿಂಗ್ ನೌ? ಓಕೆ, ನೌ at least little confidence is there now regarding, see, by this example, at least regarding UVL variation, all little more idea or knowledge came regarding UVL etc. and also equilibrium, little more extra knowledge. No, regarding UVL and equilibrium, little more extra knowledge. Yes or no? No, gottilla ನನಗೆ. Yes, okay. Now we have to go for SFD&BMD. Now I think this will take only 1 hour. And most probably, second problem will take half an hour. So most probably tomorrow class we can close both, but I will not hurry. I will not hurry. If requirement is there, one more class, no problem. If requirement is there, one more class. Because once for all settlement, combined footing, when pressure is non-uniform, how to draw SFD&BMD will be fully understood by my class. Okay, already 9 o'clock. Thank you. Tomorrow we'll continue. See, remember now, tomorrow these two I require. I will take a photograph. Otherwise, okay, right now I will take a photograph of this one and this one. Photograph I will take. When I start tomorrow's class, you can see this diagram, you can see that diagram. But actually, I have got another class tomorrow. So once I have to rub the board, no other way. I will rub the board before your 7:30 class. I will write this diagram and these two I will write once again. Okay, thank you. What all told today, thoroughly understand. Remember, it is a question of understanding once and struggling once. Knowledge will remember forever. People don't think that way. Little effort you put and you will see the difference in your approach. You will be a completely changed person in the structural knowledge. If you give interest. That's why all the SFD&BMD classes go through again and again. So time illa like that. Okay. Thank you.